Okay, here we are with question number 2, which is also solving by elimination. Now these equations have fractions, and we worked with equations with fractions back in our review unit, and the process is still the same. To make an equation easier to work with, I would eliminate the fractions by multiplying each term by the common denominator. So if I look at equation number 1, here in the first one, I see a denominator of 3 and a denominator of 2. If I were to take that equation and multiply every term by 6, that will eliminate my fractions, and then the equation will be more comfortable to work with. So I'm going to take equation 1 and I'm timesing it by a value of 6. And in doing so, if I multiply everything by 6, I'm going to have 6 times x over 3, and then plus 6 times a y over 2, and then equals 6 times the 1. And that will leave me with 2 x's, a plus 3y equals 6. And that looks much more like our previous equations. Now number 2, I'm going to take it and multiply it every term by 12, since 12 is the common denominator. So I'm going to have 12 times the negative 2x over 3. I'm going to have plus 12 times the y over 4. And that's equal to 12 times the 3. So even though the 3 wasn't a fraction, everything still needs to be treated equally, and we still multiply it by 12 as well. All right, 12 divided by 3 should be 4, and then 4 times negative 2 would be negative 8 x's. 12 divided by 4 is 3, so we're going to have a plus 3y, and that's equal to 36. Okay, those look much easier to work with. I'm going to call that 1b and this one 2b. To be or not to be? If I look at those two equations, I see that my y's have the same coefficient. So I'm just going to write 1b underneath of 2b, and I'll have a 2x plus 3y equaling 6. I have the same coefficient, so if I subtract, that will eliminate those y's. So 8x's take away 2x's would be negative 10x's. 3y take away 3y would be 0 y's. 36 take away 6 would be 30. Divide both sides by negative 10 to get x by itself. We're going to have x is equal to negative 3. And then we're going to sub x equals negative 3 into, looking at my two equations, I think I'm going to put it into 1b. I really don't want to put it into one of my original equations because then I have to work with fractions, and yeah, I'd rather not. So we're going to have 2 times the x, which is negative 3, and then plus 3y, and that's equal to 6. So that's negative 6 plus 3y equals 6. I seem to be moving this around a little bit by accident. There we go. I'm going to add 6 to both sides to undo the minus 6 here. Add 6 on that side, but add it to the other side to keep it balanced. We have 3y's equaling 12. Divide both sides by 3, and we get y equals 4. So our solution in this case would be the point negative 3, 4. Therefore, the solution is there. Squeeze that in. Okay, try the next example, and then I'll put a solution up. Put me on pause. Okay, I've started question B by multiplying the first equation by 6, and when I did that, I ended up with x take away 1, and then minus 6y equals 36. And then I added 1 to both sides just to tidy that up, and it left me with an x minus 6y equals 37. So I'm going to call that 1b. And then equation number 2, I multiplied everything by 4 to eliminate the denominator of 4. So I have 4 x's, and then take away, I'm going to have the 1 plus y in brackets, so that takeaway has to multiply through that bracket, and then 4 groups of 8 is 32. So I've got 4x take away 1 minus y equals 32. I added 1 to both sides, and I have 4x minus y equals 33. So that's my equation 2b. Now, if I look at my x's, I had a 1x in the first equation and I have 4x's in the second. So an easy route could be to take 1b and multiply it now by 4, and that would make my x's the same. Or in 1b I had a minus 6y, and in 2b I have a minus 1y. I could multiply equation 2 by a 6, and that would set the y's up to be the same, and then I could eliminate them. Now I find it easier to multiply by 4 than I do 6, so I'm going to multiply equation 1b by 6. So 1b times 6, so equation 1b times 6, I'm going to end up with, I said 4, and then I wrote down 6, and I'm getting all mixed up. I'm going to go with 4. So let me try that again. I'll write in 4 here. All right, times it by 4. So 4 times the x would be 4x's. I have 4 times minus 6y would be minus 24y. And then I have 4 times 37, and I'm checking that on the calculator, and that's 148. Just want to make sure I get that correct. Okay, so equation 2b, I'm going to line that up underneath. I've got 4x minus y equals 33. Now to eliminate those x's, I'm going to have to subtract. So I'm going to put my subtract out here. I'm subtracting everything. So 4x's take away 4x's. That's gone. I have minus 24y. Now add y would be a negative 23y. Oops. Oh, well, I'll do that in red. And then I have 148 take away 33, and I get 115 there. And then I'm going to divide both sides by negative 23, and surprisingly that does go nicely. Y is equal to 5, and then my sub y equals 5 into, and I'm going to pick an equation. I could pick 1b or 2b, or I could go back to my originals, or I could even pick the 4 times 1b, but I don't know why you would, because that would be a lot bigger. I'm going to pick 1b because I have a positive 1x on that one. It requires less work to solve for the x. So I have x minus 6 times the y, which is 5, equals 37. 6 times 5 is 30, so I've got minus 30 equals 37. I'm going to add 30 to both sides to eliminate the 30 from the left side of the equal sign, and we get x being equal to 67. So my solution is 67, 5.